Hello everyone. Today let's learn about the most powerful concept in Springs known as aspect-oriented programming. So, what exactly is aspect-oriented programming? So, let's learn step by step. First, let's go through the agenda. Agenda says, first we need to know why Spring aspect-oriented programming is needed and advantages. Terminologies or the concepts of Spring AOP, implementing AOP with Spring, how exactly we implement it. So now let's go and understand why we need Spring aspect oriented programming. And first of all, when we develop any application, we are having some features like logging, profiling, tracking, session tracking, security features, etc. So these features are some powerful features which cannot be expressed in the form of object-oriented principles or the procedural paradigms. So aspect-oriented programming is a new programming approach to address these cross-cutting concerns in an application. So what are cross-cutting concerns? These are nothing but the features that I mentioned above, that is logging, profiling, tracking, session tracking, security. These features are called cross-cutting concerns or concerns in an application. So let's see how object-oriented programming and aspect-oriented programming are similar. See, in object-oriented programming, we have every entity termed as an object, every real-world entity termed as an object. But in aspect-oriented programming, we are having every entity termed as aspects. So, here AOP is not trying to force on, or it is not trying to replace the object-oriented programming. Instead, it implements and adds on certain additional features to handle the application. So, but that doesn't mean that the features are implemented directly along with the code. No, the features are separate and business logic code is separate, because if we combine both, it may lead to complexity and data redundancy. So, both the features, that is features as well as the business logic code, are implemented separately. So, it will not affect both are independent of each other. So we are implementing and programming each feature separately from the business code. This helps in resulting in clear and understandable code, as well as it reduces the complexity of the code and improves the logical modularity of the code. So overall, these are all the advantages we can say in aspect-oriented programming. First is, it reduces the data redundancy, complexity of the code, improves the logical modularity, and it makes the code clearly understandable because we implement the features and the business logic code separately. Along with this, AOP has the most important objective, that is to handle the cross-cutting concerns in an application, that is features like security, logging, session management, tracking, profiling, etc. These are not handled in object-oriented programming. So this is in one way which makes the aspect-oriented programming more powerful. So let's introduce what is AOP. As we already saw, it's a programming paradigm to support and complement the object-oriented programming. Neither it is trying to replace the object-oriented programming, nor it is trying to force on, or it's not trying to do anything to OOP paradigm. Instead, it is trying to complement and support the object-oriented programming by handling the features which are most powerful and add-ons to the OOP, like security, logging, transaction management, etc. the goal or the objective of the aspect-oriented programming is to separate the concerns and the business logic, as we already discussed, that if we include both in one place, it may add to the data redundancy and complexity. So we always try to maintain separating the logic and the aspects or the features, important features of the aspect-oriented programming. Let's consider a web application where the user submits a form to the servlet. This servlet processes the form and returns the response to the user. Though the logic and the code is very simple, if we add the cross-cutting concerns like exceptional handling, session tracking, security, logging features, which are very important, then the code will become complex, or it will also become huge, excessively large. So what AOP does, AOP dynamically modifies the business logic to include the code for implementing the common cross-cutting concerns in an application. So there is no alteration required in the original code. So what is an aspect? Aspect or a concern, whatever it has been declared it is a model representing a concern. What exactly is an aspect? The definition for aspect is it's a model representing a concern. It's kept as a separate source code. So how should we declare an aspect in a file or an application? It should be robust. Robust in the sense, if we change in one aspect, it should not have much impact on the other aspect. Second is systemic, that is, it should not affect the target program at different places. Third feature is cross-cutting. Cross-cutting is each aspect or the feature should cross-cut other aspect. Fourth is loosely coupled, that is, it should not show the details of another aspect. One aspect should not show the details of another aspect. Apart from all these four features, an aspect should also contain the join points. So what exactly is a join point? We will discuss in our next slides. So these join points are used to combine the aspects. In other words, what we can say is aspect-oriented programming intends to solve the problems of the common cross-cutting concerns by programming these concerns separately apart from the business code. So we also have certain terminologies or the AOP concepts, we can say, which are very important in order to learn the aspect-oriented programming. These terminologies understanding is also of very much important. So let's list down one by one. First is concern, cross-cutting concerns, aspect, join point, point cut, weaving, introduction, target and proxy. So let's go ahead with one by one. Concern. What exactly is a concern? It's a feature which represents a particular property different from the programming logic, which needs to be effectively addressed. So what exactly is a concern? As we already discussed, session tracking, monitoring, security and transaction management. Cross-cutting concerns are logging and validation. Certain concerns which are applied to all the components in an application. Aspect. Central unit of AOP nomenclature. It's the very important unit and is similar to the classes in OOPS. So how exactly it looks like? The syntax is as follows. Aspect modifier, aspect name extends class or an aspect, implements interface list, and the aspect body, here the aspect declaration. So how exactly it looks? So here we can see the syntax of an aspect. Here in this code snippet we can see the syntax and how the declaration has been done. Here the keyword is aspect, which specifies the declaration of the aspect. Here also it shows the point cut and advice declaration. So the point cut declaration consists of the keyword called point cut and method execution on which the point cut is executed. So greeting here is the method declaration, and the advice declaration consists of the after declaration, which is executed after a method is returned once the execution is completed. So here greeting is returned back. Join point. What exactly is a join point? It's a well-defined point during the execution of an application. We have few actions like method calls, object creations, field access and exceptions throwing. These are performed during the program execution. So if an aspect is declared on a method call, then the advice applied at that particular instance of the call is called the join point. At that particular, during the execution, whatever we apply. So examples are during the method invocation, during the class and field initialization, object initialization and field access. Next comes the point cut. Point cut is a point of execution at which the cross-cutting concerns are applied. So what happens is, when a method is executed, this point cut matches that particular method execution on which the advice is executed. So it's an expression which describes a set of join points. So what happens is, when a set of join points is selected during the method invocation, an advice is applied. So these are the four types. General point cut types are as follows: call, that is calling any method; execution, method on which the cross-cutting concerns are applied; target, it's a method which executes a join point when a target object is specified as a method argument; and args, this method is used for version matches if an argument is passed at the runtime, if it is serializable. So point cut can also be classified as static and dynamic. So what exactly is static? When an advice is based on the information at the compile time if it happens, it is said to be static, that is getter or setter method invocation. When the runtime information is available and an advice is executed conditionally, dynamic criteria is involved. So what exactly will be the syntax? Access modifier, point cut name, parameter list, point expression, advice. Okay, before that let's learn some point cut syntax. See, here we are having execution. Execution will have the method signature as the parameter inside it. Call will have the method signature inside it, that is calling a method. Execution will have the constructor signature inside it, etc. We also have getters and setters which will have the field signature inside it as a parameter. Okay. Next, advice. What exactly is an advice? Advice is a logic which consists of the actions applied in the case of method execution. So it means the actions taken at a particular join point. In addition to this, it is also an executable code which runs when a join point is encountered in program execution. Let's Before getting into the advice part, let's understand a situation where a Java programmer creates a program. The name of the program is P1, in which there are two methods, M1 and M2, which are executed. So what happens here is the point cuts P1 and P2 are created at execution points for applying any advice. So a join point, what it does is it denotes two previously declared point cuts. Okay, now let's get into the advice part. Advice is a logic which consists of the actions applied in case of a method of execution. It defines the actions taken at a particular join point. In addition, it is an executable code which runs when a join point is encountered in a program execution. For example, let's see, an advice can contain actions such as logging, validation related to a method execution. The advice can be of any of the following type, that is before, after, or around. It can also be after throwing, after returning. So what exactly is before? Before the method execution, if we apply the advice, that will be the before. After a method call, it will be after. During the method call, it will be around, and the other two are after throwing, that is executing the advice after an exception is thrown during the method execution. After returning is advice is executed only after returning from a method execution. Let's learn about one of the important concepts while learning AOP is annotations part. Our Spring framework recommends usage of Spring Aspect AOP implementation over the other paradigms because it provides us more control and it is easy to use. There are two ways of using Spring AOP Aspect J. One is by annotation, second is by XML schema based configuration. Annotations usage is rather very easy. So let's see how many provisions are provided by Spring AOP for the annotations. If we use @aspect, it declares the class as aspect. @point_cut, it declares the point cut expression. Then @before declares the before advice, that is before calling the actual method, as we already discussed here. Different types of advice. So how it is used with annotations is what we are seeing now. @after, that is declaring after the advice, that is once the actual method is called but before returning the result. After returning, @after returning means after returning the advice, that is it is applied after calling the actual method and before the returning result. Then @around, it declares the around advice, that is before and after both, before and after calling the actual method. After throwing is throwing, after throwing an exception. When a method throws, in case if the method throws an exception, we are having after throwing, that is after throwing the advice. So now we can easily understand all these annotations as well as the types of the advices using the code snippet below. Before execution, the code dot display here, this is the method before execution. So what exactly is the method? This is the before advice example. Method before is the name of the method. A method is going to be executed is what we are printing here. After returning, here again we are having execution, the method, and the method after system.out.println after returning the advice. Next, this is around advice. Around advice is after execution code.display, here the method name. This is after throwing, that is around execution code.display method around. Everyone, let's continue with the weaving process. Weaving is the process of inserting the aspect logic, or we can also say handling the cross-cutting concerns as at a specific join point, like executing a method. When the execution of an application reaches a particular configured join point, an advice is made. Point cut specifies when an advice should execute and identify a join point, an advice is made. As a result, the weaving is complete. Weaving can be done either at the compile time or the run time. So, if we have a logic, business logic or the aspect, wherever we need it, we can insert that. So that process is called weaving. This is done during the method execution. Next terminology is target. Target is nothing but it is an object on which an advice is made and whose execution flow has been modified by an AOP process. A target object is being advised by one or more aspects. Target object is also known as advised object. The implementation of an aspect in the Spring framework is done using runtime proxy. Therefore, the target objects follow the proxy arrangement done by AOP infrastructure. So this is the final object. After the execution, whatever the modified version of an object is formed by an AOP process, that object is called the target object. Proxy. Proxy is nothing but it's a security feature where the security arrangement which is implemented for either a method execution or a field access. AOP builds a proxy for implementation of a method. Proxy is weaving the original code and advice at a join point. As a result, for example, when a client calls a method, the call is transferred to the proxy, where validations and authentications are performed. Only after following the proxy setting, the actual method is called. So, this results in secure method implementation. There are three most popular AOP frameworks available in the market. Those are AspectJ, JBoss and Spring framework. AspectJ is nothing but, as we can see, these are the three main AOP frameworks in the market. AspectJ is the framework which is very popular in the Java community. So the syntax of AspectJ is almost similar to that of the Java language. Next, JBoss. JBoss is also another framework where the aspect, advice and point cut declarations are made in the XML file called JBoss XML or the JBoss AOP.xml. The advice is implemented using Java methods and invoked by the JBoss AOP framework. Spring framework. This framework does not provide the complete AOP implementations. Instead, it focuses on solving some issues which are common to the inversion of control and AOP. In Spring, as we all know, AOP is implemented in Java and aspects are entirely declared in the XML document. So, AOP is implemented in Java and Spring supports cross-cutting concerns related to the methods executed on the beans only. So, AspectJ is more suitable than Spring AOP framework for advising, field access, etc. The next very important section is implementing the AOP in Spring. Just now we learned all the annotations Aspect J framework, related to Aspect J framework, AOP terminologies or the concepts, everything. Now let's look into how we implement all these things in Spring. Let's imagine this. First, this is a very important concept, that is the calling code here. It calls on the proxy, which in turn calls on the POJO or the plain old Java object. The proxy here calls the POJO and the return is done here back to the calling code. So the implementation of the AOP is proxy based, and also it supports auto proxying. Auto proxying is also another mechanism here. What do we mean by auto proxying? It means if a bean is advised by one or more aspects, Spring what it does, it will automatically generate a proxy for that particular bean to intercept the method invocation and ensure that the required advice is properly executed. The proxy is used to authenticate the access of the fields and the methods. The request is first transferred to the proxy. Therefore, it is the responsibility of the proxy to forward it to the concerned sources to process it. The principle of the proxy design. What exactly is the principle? Let's know the principle. The principle is to wrap the object with the proxy. Whatever the object that the calling code is requesting, that will be wrapped with the proxy and it is used as a substitution for the original object. Therefore, any call that will be made to the original object first goes through the proxy. The proxy is also responsible for the crucial decision of the forwarding the method call to the real or the actual object. Due to all these features, proxies are used very much in the implementation of the AOP or implementation of the cross-cutting concerns in Spring AOP. So proxy forms a very important concept in implementation of the Spring AOP. So if we remember this particular flow, that is calling code will call through the proxy and embed all the objects, and then which in turn calls the POJO or the plain old Java object, and even the return is made in the same order, that is returned back to the proxy and again to the calling code. This flow is very important. This flow is also known as proxy based system. This method is called proxy based system. A method is called on a POJO. POJO, as we all know, it is a plain old Java object, or it can be any Java class having getters and setters. So as we all know, in Spring, POJO plays a very important role and is extensively used. So due to this reason, it will neither enforce any particular interface to be implemented, or it need not extend any class in order to create a class. Instead, direct call is made to the object. The method is first called on the proxy, which forwards the method call to the actual object. So in AOP context, what it is an appropriate implementation of any advice. We use the term advice, as we all know. Advice on a particular join point. As a result of this particular utility, any method invocation is actually called on a proxy and the respective advice is properly executed. The final result is the efficient handling of the cross-cutting concerns. So here POJO, it helps the programmer from defining any predefined annotations in the class. So that's the reason it is also known as plain old. It follows the old methodology, plain old Java objects. There will be no annotations as well. Hello, let's continue with few more point code related methodologies, or we can also call different types of point cuts which has been implemented in the recent versions. Mainly these point cuts, that is name match method point cut or the regular expression name match method point cut advisor, dynamic point cut, static point cut, all these name match method point cut advisor, these point cuts have been introduced in the later versions of the most recent versions of the Spring. So let's go through it. So first, before all those things, let's recall let's recap what exactly is a point cut. Point cut is a point of it's a point of execution at which the cross-cutting concerns are applied. It matches a method execution on which an advice is executed. So, whenever the program execution reaches a particular join point or a particular point, an advice is executed. What is that advice? Advice is a code associated with the point cut. So, all these terminologies go hand in hand during the method execution, before the execution, or in and around the method execution, or after the method execution. So, point cut is, in simple terms, it's an expression that defines or describes a set of join points. So, when a set of join points is selected during a method invocation, an advice is applied. Already we discussed that there are 4 general point cut types, that is call method, execution method, target method and args method. And we also saw the syntax. Now let's see different point cuts, that is name match method point cut. What exactly is the name match method point cut? It matches for the simple method name. See, first basically what we need to do is, in the main method we need to import this org.springframework.aop.support.namematch method point cut. We need to import that particular class, and later what we do is we see whether it matches for the simple method name. There is also an alternative, that is regular expression patterns, but it does not handle the overloaded methods. So what is declared in the bean class? We need to see. Bean XML is bean ID name, class, the name match method point cut class package, property name and the value. Bean is enclosed. Then we see how in main class it is used. Let's see. This is a public class, main class, inside which we are having the main method, public static void main method, where first we need to import this name match method point cut. We are creating a constructor out of it, and we are adding some method names like say hi, greet, everything. All these will be displayed later once we run this program. And we also creating a constructor for advice, advisor, everything. Later on what happens is, here it is saying hi Nagashri, proxy bean.say hi and greet. So this is the way we need to use the name match method point cut. Next is regular expression name match method point cut. Here it is also the same way. In the bean class we are calling this entire class based on the property name is patterns and the value is business dot. So the list of values starting with business dot, before and after also there can be patterns, will be displayed. Next is name match method point cut advisor. Here again we are including the class name, that is r.springframework.aop.support.namematch method point cut, but here property name plays a very important role as well as the method name. Value is the method name, property name is the property name here.